common emitter bias configuration. So we're continuing our amplifier part. Okay, so we're seeing different combinations. So this is common emitter. Common emitter bias configuration. Okay, so you have VCC. Okay, then you have a transistor here. Common emitter. You have a RC. You have a RE. Okay, and then you have a RB. Okay, and here we are giving V input here, and we are taking V output here. Now, there's a difference between this circuit and previous circuit. Okay, in previous circuit, what we have done when we are doing voltage divider, I have put one capacitor here. So once you put capacitor here, this automatically becomes 0. This becomes short. Okay, so in this case, I'm not putting resistance here. So now we have to make equivalent circuit for this one. So obviously you have to do DC analysis and you have to find this RE value, this resistance RE. Okay, so now equivalent circuit would be what? So equivalent circuit, this will be open, this will be short. Okay, and capacitor will be short for AC analysis, and this become grounded. Okay, and now the same, similarly we will make equivalent circuit. You have V input here. Okay, you have RB, which is grounded. Okay, then equivalent circuit of this one, equivalent circuit of transistor, that is we have to replace this by a resistance beta RE. Okay, now this time, see, this time this resistance is there. Okay, so we have to consider that resistance also in this equivalent circuit. Okay, so there will be slightly change in your equivalent circuit. So see, this is V naught. So equivalent circuit this time will be V input RB. Okay, then you will be having beta RE, beta RE, this resistance. Okay, this resistance beta RE. Okay, and series this resistance also there. So you have one more resistance RE also there. Okay, this is your input. Similarly, if you see output. Okay, now output is not grounded. Earlier this was grounded, so resistance was there. So your output will be like here. You will be having current source here, beta IB. Okay, and then you have here, you have this circuit RC, which is grounded, of course, which is grounded. Okay, or you can put slightly parallel, so you can make like this also. Okay, so but this time you have to remember this beta RE is not connected here. So what I have to do, I have to replace this one like this, and I have to replace this here. This is the correct circuit now. So beta AB, and this is your V naught. Okay, beta is not connected to output terminal. This terminal C is not connected now. So this is your equivalent circuit. Now for this circuit, you have to calculate again all the parameters. Okay, like ZI. So let me calculate now for this, for Z impedance. Okay, Z impedance is what? The thing V input, I input. Okay, so before, now here this one circuit RB is common, same. Okay, Now instead of beta RE, now you have this combination. Let me call this combination Z beta. Okay, J beta. Okay, so JB. So JB is basically what? This is your beta RE. Okay, and here current, here IB current was flowing, and here you know what current was flowing? IE in circuit, and RE IE current is flowing. That is beta plus one, but beta plus one IB current flowing. Okay, so this become RE, beta plus one RE. Okay, so this circuit become now ZB become your beta plus one RE. Okay, so instead of IE in the circuit, I am writing beta plus one IB RE. Like I am writing here beta RE. Now I am writing here this is beta plus one RE. Okay, so this is my ZB, and my Z input will be simply parallel combination of RB and ZB. Okay, this combination. Of course, you can say beta RE is negligible compared to RE. Okay, so if you can leave this one also. So if you want approximation, you can do approximation also, but not required. If you want, you can do approximation. So this will become beta RE plus RE, because beta is generally greater than one. So you can put this also. Okay, so this is the formula, and you can now do approximation. Okay, you can also write JB equals to simply beta RE. Okay, because in general your RE is greater than your RE. So you can also write like this. Okay, and Z input is your simply RB parallel to JB. Okay, if you want to calculate ZI, so you know ZI is we can calculate this VI. Okay, VI upon II, VI upon II. Okay, and II, how can you calculate II? You should know II is simply what is the form, what is the value of II? Okay, suppose I current one this one, so I have to take decision this one total. Okay, so this will be simply ZB. Okay, so this will be ZB, II will be ZB plus RB upon RB into IB. This we have done earlier several times. Are you getting how am I writing this one? Are you getting how I am writing this one? VI is what? VI is equal to this one and this one. So VI is nothing IB ZB. Okay. Now if I divide this by VI by ZI, so VI by so IB, so ZI will be what? IB ZB upon ZB plus RB IB into RB IB cancel, and this is nothing. This is just a parallel combination of RB ZB. That's what I written here. So whatever we are doing earlier, that is same case. Here was RB or R dash one resistance was there, and here now is one more resistance there. ZI is a parallel combination to this term. Okay, this time I'm assuming R naught is infinite. Okay, so V naught will be simply, so I naught is coming from here, so V naught my Z naught will be simply RC. Okay, so Z naught will be simply RC. So ZI, you know, Z naught will be simply your RC. Okay, now I want to calculate this gain, voltage gain and current gain. So let me now write for voltage gain. Voltage gain is AV. Okay, V output upon V input. Okay, and V output, you know what is, this was minus, this current is coming beta IB RC, so minus beta IB RC is V naught, and V input just now we have seen. Okay, what was V input? V input is this one. Okay, IB into ZB. So IB cancel. So your A gain, voltage gain is nothing minus beta RC ZB. This is my gain formula. यहां तक कोई डाउट है क्या? Okay. The next thing is you need to calculate current gain. Okay. So let me now calculate current gain. Current gain भी same निकालेंगे जैसे पहले निकाला था हमने. You should know I naught. Okay. So current gain is I naught upon I input. Okay. And I naught is simply this is equal to beta IB. So beta IB and I naught just now I written earlier. Okay. I naught is what yours? ZB plus RB upon RB into IB, I input. Okay. So this will cancel out. Is this correct formula? I का formula क्या था? I input का यही था क्या?
Yes, sir. Yes.
Okay. So this will become beta RB ZB plus RB. Okay. So this is your gain formula. Okay. Now I will give you one more simpler formula. So suppose in amplifier circuit, okay, sometime you are not able to calculate this current gain, okay, but you can calculate your voltage gain easily. So there is a simple formula, approximate formula, which is always applicable. Okay, are you getting? So when there is one formula relation between AI and AV, okay, that is always applicable. Relation between AI and AV. Okay. So what is relation between AI AV? So from here itself, I can find a relation. So you know what is my ZI? Okay. So so AB you can write here. AB is what here? Beta RC upon ZB. Beta RC. So you can convert this one. You multiply by RC. You have a RB. Multiply by RC and divide by ZB. ZB. Okay. Or what I can do? I can bring here beta. Okay, I can multiply this by ZB and ZB RB ZB plus RB divided by ZB. Okay, now this become my Z input resistance. Okay, so this become my AI beta ZB ZI, isn't it? Okay, this is my ZI. Now I want to bring here again AV. Okay, so AV is what? Just now we have seen what was the formula for AV. AV was my beta RC upon ZB. So AV was minus beta RC upon ZB. Okay. Now ZB is there, beta is there. You multiply by RC. So RC beta RC ZI divided by RC ZB. Okay. And so this become what? Minus beta RC and ZB. This become your AV. So this become minus AV ZI upon RC. Okay. So this is your formula for AI, and this is always valid. So if you know the circuit, you can calculate voltage gain and impedance. Then you can directly find from the value you can find the current gain. Okay, so this will give you approximate value very less different than your actual value. Okay, so approximate value will be correct. Now let me solve some previous year problems. So I have a transistor. Okay. V naught VCC R1. So this is R1, R2. Okay. And this is your R3. And here I'm giving V input. This problem came GATE 2017. Okay. And R1 value is given 10 kilo ohm. R2 is 10 kilo ohm. R3 is 1 kilo ohm. Beta is given 99. Okay. Yeah, asking what is the value of Z impedance. Okay. Neglecting the base emitter junction. Neglecting the base emitter junction. Okay. See, just one value they asked. So the amplifier question generally will be very easy, but students do mistake. Okay, they think this part is tough, so they don't prepare for exam. So don't do this mistake. Okay, very simple question is now this asking what is the Z impedance. Okay, so you know what Z impedance. Z impedance simply parallel combination of what R1. If I take equivalent circuit for this one, this we have to make ground AC analysis. Okay, so now this will be what R1, R2 will be also ground, and this is already ground. Okay, so here what will be, this will be RE, beta RE, and then this will be your R3. Okay, now you say neglect beta RE. So this already they have neglected beta RE, so this is also not there. So only you have 3 resistance here, and they are asking what is the Z impedance. So Z impedance is simply parallel combination of this one, R1 parallel to R2 parallel to R3, and this is your answer. Tell me what is the answer.
Sir, this is voltage divider.
One voltage divider. Okay, and one thing here this also you have to modify, na, because this current is I, not IB. So this will be, when you make AC circuit, this will be replaced by beta plus 1 R3. This is voltage divider circuit. In voltage divider circuit, I am not putting here resistance. Oh, capacitor I am not putting here. So this will not be neglected. Okay, now it become beta plus 1 R3. This you have to remember. How to convert IB into IB, because the current is coming here. This is IB, not IE. So you have to write in terms of IB. So this will be beta 1 plus IB. So automatically you have to multiply this vector with this vector. So it's become beta plus 1 R3. Okay.
सर इसमें आर ही नहीं आएगा, वो जो स्मॉल आर
वो आ रही तो क्वेश्चन में बोल रहा है ना, नेग्लेक्ट करो. क्वेश्चन में वो बोल दिया कि नेग्लेक्ट करो इसको. अगर नेग्लेक्ट नहीं करता तो यहाँ पे सीरीज में आ जाता, बस और क्या. If you are not neglecting, then this will come like here beta RE, beta small RE. Okay, but in particular question they have told to neglect RE, so I'm neglecting. Okay, क्योंकि VCC वगैरह का DC का वैल्यू दिया नहीं है, that means you have to directly correct. You don't need to correct this RE value. Okay, sometime what they will give you RE value also, so that you should not do AC analysis. Okay, because once you do AC DC analysis, question become little bit lengthier time. Okay, so sometimes they directly RE, this time this is neglect. Okay, tell me the answer.
Sir, 4.76 or
4.76 kilo ohm is the answer. Okay. So the value is given, you can calculate what is your ZI. One more question I'm giving on based on this voltage divider only. Okay, so voltage divider के ज़्यादा question आते हैं exam में. So they have given you voltage, they are calculating here. VCC they given, okay. VCC they given 16 volt, okay. And here they put capacitor C2, V0. They are putting resistance here. V input they are doing here, okay. And RE, so here they are putting one more resistance, RC, and 16 volt, okay. RC value they have given 2.2 kilo ohm, okay. And R1 value is they have given 90 kilo ohm. R2 value they have given 10 kilo ohm, okay. And RE value they have given 0.68 kilo ohm, okay. So they are asking find out RE, ZI, Z0, AV, AI, okay. So RE is nothing, 26 millivolt upon IE, okay. And this particular question, if I do with approximation, okay, IE is nothing, IE is your just VE upon RE. RE is given in the question into one VE, okay. And you know VB, you can find VB here. So once you know the VB, okay, VB is your VB, so VB will be your VBE plus VE, okay. So if you want VE, VE will be your VB minus VB. VB you take 0.7, 0.7, okay, and calculate VB. So VB is simple. VB is your just voltage division. So you have R1, R2. R2 is what, 10 kilo ohm. 10 kilo ohm upon this is 10 plus 90, 100 kilo ohm into R2 upon R2, and total is 16. 16. So this become 1.6 volt. So VB is your 1.6 volt. Okay. So you can find now VB, you know. So you can find VE. So VE will be your VB is 1.6 minus 0.7. Okay. So this becomes 0.9 volt VE. Okay. So you can find now RE. RE will be 26. Sorry, RE will be now. So IE. So first unit for IE. So IE will be yours 0.9 volt divided by 0.68 kilo ohm. Okay. So you know these things. Tell me what is the IE value now?
$1.3 milliampere.
1.3. Okay. So 1.324 is there. Okay. 1.324 milliampere. Okay. So once you know this thing, you can find RE. Okay. So now I'm directly writing the values because now there is just calculations. Okay. So RE is nothing. Small RE is nothing. Okay. 26 upon IE, and this should come 19.6. 19.637 ohm. 19.637 ohm. Okay. So once you know the RE, you can now find ZI. ZI is again very simple. Okay, this say this is R dash, or you can say R1 dash, R2 dash. Okay, and this will be combination beta RE, beta RE plus, or call this as a ZB. Call this as ZB. Okay, ZB, and ZB will be what? Your beta RE plus beta plus 1 RE. Okay. So R1, R2 value given. You can find RE value also given. You can find this one and solve and tell me what is coming ZI.
बीटा क्या
Values
Beta,
beta.
beta question में दे रखा है. Beta value लिखा 99 something ना. Beta value is 9. 1 minute. Beta का value कितना है? Just RB 9 kilo ohm. Beta you take 210. 210. ये 210. Or tell me what is the value of ZI and Z naught. Now amplifier में the procedure is same. Okay, there may be a little bit variation in the circuit, but the process is same. So I will do one more tomorrow, one more configuration. Okay, that is a little bit different. Otherwise, all the things what I taught, the question will be based on this type of configuration only. So tell me what is the value of ZI, Z naught? And of course, you find gain also. Gain formula already are given. Gain formula also you know for this case.
ZI कितना आ रहा है?
8 point something आएगा. How much is coming? Anyone? I was 8 point something, 8 point something ohm. Okay. R1, R2 is given na. R10, 10, 90. How much? So first you calculate ZB. ZB value कितना आ रहा है? ZB value कितना आ रहा है? Okay. So I am putting the value. Okay. I am putting approximate value. इसके आसपास जाएगा check करना. भेजना मुझे. थोड़ा वो there will be little variation. Okay. So no issue. So 2.2 kilo ohm. And then I'm giving the gain value is minus 3.24 and the approximate value of I gain, okay, is 12.47. You just check it and tell me tomorrow. Okay, note down the values. Okay, so gain formula will be same. Any question?
Sir, note करना है sir. ZI is in ohms or kilo ohms?
Ohms में. अब देख लेना किलो में ओम में मेरे पास लिखा हुआ नहीं है. ओम में होगा शायद. 3 kilo ohm, kilo ohm. Okay. See, these are all kilo ohms ना. So देखो कट कैंसिल होता ही नहीं होता है. चेक करना इसको. Okay, so I'm erasing this one. Equations, writing equations very simple. Just you see the circuit and calculate. Now this particular question say, now the problem what we have done today, here we was having RB here, RE here. Okay. So this particular problem, you have been given RB value 470 kilo. Okay. RC value, you have been given 2.2 kilo ohm. R naught is given infinite. Beta is given 120. RE value is given 0.56 kilo ohm. Okay. And you have been asked, say this V input, and this is your V naught. Okay. Of course, there's a capacitor there. So you have to calculate RE, ZI, Z naught, AV, AI. Okay. Just tell me the value of RE. Remaining is homework. I will put the answer. Just calculate RE. RE. RE and ZI both to calculate. And values, voltage is, this is 20. This is 20. So first you need to calculate IB. Okay. So IB will be nothing. IB will be simply VCC minus BBE, that is 20 minus 0.7. Okay. And IBRB, that will be RB plus this one, beta plus 1. Beta plus 1 RE. DC analysis first. And your IE will be beta plus 1 IB. Okay. Tell me what is IB value? Or IE value? So tomorrow there will be last class for analog. Okay. We'll focus on only digital. कितना आ रहा है? 35.89 आ रहा है क्या? And this should come 4.342 milliampere. Okay. ZI value is, I'm directly writing the values. Okay. 59.345 kilo. Okay. ZB value, okay, 67.918 kilo ohm. Z naught value 2.2 kilo ohm, only equal to RC. A gain is coming 104.92 approximately, and AB is coming minus 3.89. Okay, these are the values. You need to send me the homework. Okay, so we'll meet after 5-minute break for your digital.